Okay, so dear students, viewers, welcome to today's class. So today, in the previous session for the gravitation, the topics which were pending were Kepler's law of planetary motions or three laws of Kepler's. Okay, so today I'll be will not the session will be not a long session. It will be very short, just for a few minutes, like 5 to 10 maybe. So let's start it. Okay. So today we need to study the remaining topics in the series of gravitation, that is Kepler's laws of planetary motion. So Johannes Kepler in 17th century, together with his mathematician calculus friend, that is Tycho Brahe, they formulated the laws of planetary motion, which were actually known just to give the respect to the scientist Kepler, as the name Kepler's laws of planetary motions. So at first, Kepler basically gave three laws. Okay, Kepler's first law of motion, law of orbits, then law of time period, and law of areas. Second is the law of it's the law of areas, areal velocity law. So at first we'll see the Kepler's first law, that is the law of orbits. Okay, so basically it says all the planets you can see on the screen. We have the screen here. We have the screen. Okay, all the planets basically revolve around the sun. Okay, these are this is basically, you can see this is the planet. Okay, and all the planets, it's not just about the earth. Kepler just gave the observation, I mean, in a theoretical format, as per the first law, that all the planets revolve around the sun. That basically sun is basically at one of the foci. Okay, so the path, the thing which we must conclude from this first law is that the path is not circular. The path is basically elliptical. So the statement says, as per the first law, all the planets revolve around the sun, with sun in one of the foci of the ellipse. Okay, so this was the first law. Let's move towards the second law. So second law is basically known as the law of areas. We'll not go into the depths of perihelion, aphelion, all those things. We'll just understand via this that this expression d capital A by dt, it basically means the rate of area traversed, or the rate of area basically traveled. Okay, transversed. You can simply say it's like an aerial velocity. Okay, no need to go into the lot of depths. So dA by dt is basically aerial velocity, or the area which is traveled by the planets when it is near to the sun or it's far away from the sun. That rate of change of area. So basically, if you can see, if the planet is near to the sun, as shown by this arrow, this is kind of in a, you can see the area is like quite big. I mean, it's the area is it's having the good width. Here you can see the area is having not a same width as it was having when the planet was near to the sun. So we basically say that the aerial velocity is equals to angular momentum of the planet upon twice of mass of the planet. This remains constant. So the conclusion is this from the Kepler's second law, that is the law of areas, is that the aerial velocity is equals to constant, which is basically in turn equals to angular momentum by twice of the mass. Okay, let's move next. Then the third law, which is the Kepler's third law, also known as law of periods. Kepler observed this thing in the space that the path of the planets will be elliptical with sun at any of the foci of the ellipse. Also, he observed that aerial velocity is constant, which in turn we just subtracted L upon 2m. Then he observed that the time period of the revolution of the planet is basically its square. The square of the time period of the revolution of the planet is directly proportional to cube of the semi-major axis of the ellipse. So you know that this thing, that ellipse is having two axes. One is basically the semi-major, and one is basically the major axis, and another is the minor axis. So it's cube of the semi-major axis. Okay. So these were three laws of Kepler, and we are not going to do any question in this series now. Okay. So today I will end the session soon because I needed to complete this gravitation series remaining topics. Thank you so much. And now we'll end the session. In the next session, maybe we'll start with the elasticity properties of the materials, that is the mechanical properties and the fluid properties. Thank you so much. If you're having any comments, please give the comments in the chat box in the Zoom or YouTube. Okay. Thank you so much, everyone.